Hello dear students. So today we'll discuss vapor absorption system, and that under that category of vapor absorption system, last time we discussed the water lithium bromide pair. So in that these two systems which we selected to discuss, this water lithium bromide, and in which water act as a refrigerant. Here you can see water act as a refrigerant, and lithium bromide act as a absorbent. So this system we discussed last time, and the limitation of this system was the 0 degree centigrade. So in this system one cannot go below 0 degree centigrade. What was the reason was the water. Reason was the water, because water acting as a refrigerant, if it goes below than 0 degree centigrade, it will freeze. So that was the biggest disadvantage of this water lithium bromide system. The good thing about the water lithium bromide system is that this is widely acceptable, and moreover you can say this cheap refrigerant is there, and capacity, it is used when the capacity is very large. That's why this water lithium bromide system is used. Now in order to overcome this limitation of 0 degree centigrade, so here is another combination of the refrigerant, that is the ammonia and water. Here you can see ammonia is acting as a refrigerant and water is acting as a absorbent. So in this case we can go below 0 degree centigrade also. Okay, so we can use this type of system for the cold storage purpose also, as well as a refrigeration, this as well as for the air conditioning purpose also. Okay, so last time we discussed about this lithium bromide, water lithium bromide system, where we discuss about the COP of the system. So this is the COP of the system, where QE is there, QG is there. What is this QE? Q is the energy absorbed in the evaporator. QG is the energy given in the generator. So COP should be refrigeration effect divided by input, whatever the input is there. So in this case refrigeration effect is QE, and input is there basically whatever the heat is there plus pump work is there. So WP is the pump work. If we are ignoring that pump work, then it will be QE upon QG. This will be the COP. If we are considering the second law of thermodynamics, second law, which is the basically exergy analysis, then COP upon maximum COP. So this derivation we discussed last time, and QE upon QG is there. Then these temperatures are there. This temperature is the this temperature is the generator temperature. This is the condenser temperature, evaporator temperature. These are the temperature which you need to use to find out the this second law efficiency. Now in order to get these COPs, basically you should aware about this QE, which is a function of enthalpy, QG, which is a function of this enthalpy, or you can say temperature. Okay, so these things we should be aware. In this lithium bromide system we discussed that chart, which is the enthalpy concentration chart. Okay, from that chart we can easily find out the enthalpy of any state basically. But in case of ammonia water system, which we are discussing here, ammonia water system, that's in that earlier case, if in the generator, if this was the water lithium bromide system, जब हम हीट प्रोवाइड कर रहे थे, हीट इज देयर, हीट प्रोवाइड कर रहे थे, द ओनली इवेपोरेशन टेक्स प्लेस फॉर द वाटर. सो इवेपोरेशन इज ओनली फॉर द वाटर. बट इन केस ऑफ अमोनिया वाटर system, in case of ammonia, here we'll see that mixture of ammonia and water. So this is the mixture, this is the ammonia water mixture. Here liquid is there. In this liquid you can say water is also there, ammonia is there, also there. So once this heat, we are providing the heat, once we are providing the heat to this system, this is under a constant pressure. पिस्टन लगा हुआ है, उसके ऊपर कुछ वेट रखा हुआ है विच इज़ प्रोवाइडिंग ए कांस्टेंट प्रेशर. ओके, वंस वी आर प्रोवाइडिंग द हीट टू दिस सिस्टम, दिस लिक्विड starts evaporating basically. So first stage will be that on the surface of this one, इस सरफेस पर क्या हो जाएगा, बबल फॉर्मेशन स्टार्ट होगी. यहाँ पर फर्स्ट बबल बनना शुरू होगा. वो लिक्विड किस में, जैसे ये कन्वर्ट जो बबल इवेपोरेट होकर ऊपर ड्रॉपलेट वेपर बन जाएगा, देन दिस विल बी द वेपर. एडिंग मोर एंड मोर हीट टू द सिस्टम, कन्वर्शन ऑफ द वाटर प्लस अमोनिया इनटू द वेपर स्टेट. सो बोथ लिक्विड एज वेल एज वेपर स्टार्ट्स इवेपोरेटिंग. दोनों ही इवेपोरेट होने शुरू हो जाते हैं यहाँ पर. ओके, ड्यूरिंग दिस इवेपोरेशन प्रोसेस, जैसे वो इवेपोरेट हो गए, तो इन द अर्लियर केस जो हमने लास्ट टाइम डिस्कस किया था, दिस लिथियम वाटर लिथियम ब्रोमाइड सिस्टम, कंडेंसर, एक्सपेंशन वाल्व और इवेपोरेट, सिर्फ वाटर ही जा रहा था, सिर्फ वाटर. बट इन दिस केस इफ दिस आफ्टर द हीटिंग दिस वेपर्स में वाटर भी है, अमोनिया भी है, then this will go to a condenser, expansion valve, evaporator, which will basically reduce the capacity of the system. So it will this heat transfer become non isothermal, heat transfer non isothermal हो जाएगा. evaporator temperature will increase, evaporator का temperature increase हो जाएगा. evaporation will not be complete, evaporation complete नहीं हो पाएगी. choking will be there because water is there. If we are going below the 0 degree centigrade, choking होना start हो जाएगा. Then volume handling will be more, volume handling capacity बढ़ जाएगी because unnecessarily water है जो वो उसमें जा रहा है. So in order to avoid that thing, in order to avoid such scenario, we can use the rectifier, okay, and analyzer. All those things we can use which we discussed earlier to avoid that thing. Okay, now we'll discuss the how to find out the property of this mixture. Once water and ammonia is there, what will be the property of the mixture? So here this is the temperature concentration diagram. You can see how we are getting this temperature concentration diagram. We are getting this diagram from this basically process. This is one experiment which we performed. So as this is the first state, liquid. So here you can see this line, we will follow this line. We will follow this line. First state is that this is the 0 is representing here that pure water is there. Here you can see 1 is representing here pure ammonia is there. So this is the 0% concentration, this is 1% concentration. Okay, and I'm considering the mixture of H2O and NH3 50%, 50%. So this will give you this 1 point. And right now this is at a state of phase of liquid. As you can see, this is the liquid state. This is at a 1 point, okay, which is a subcooled liquid. So once I am giving the heat, so this point will go up and it will come here. Once the first bubble is made on the surface of that water, actually liquid. तो यहाँ पर जैसे ही वो इस सरफेस से ऊपर चला जाएगा, इट स्टार्ट फॉर्मिंग द बबल. यहाँ पर वेपर बनना शुरू हो जाएंगे. स्टिल वाटर इज ऑल्सो देयर. और ही हीट ऐड करेंगे, सारा का सारा लिक्विड किस में बन जाएगा, वेपर फेज में बन जाएगा. उसके बाद सुपर हीटेड रीजन. सो दिस विल बी द फिनोमेना, so which we discussed in the previous slide also. So this will be the complete liquid, this will be the liquid plus vapor, this will be the vapor at a constant pressure. Okay, at a constant pressure. So here if we are changing the concentration, this line will shift. अगर इस साइड गए तो ये concentration बढ़ जाएगी, इस साइड गए concentration कम हो गई. Now if we need to find out this at a particular temperature, so this concentration is there and say some temperature is also given to you. So corresponding to that temperature and that concentration, this point will be there. So say this 2 point will be there. So as per this 2 point, what is the liquid, what is the vapor, what is the total mass, what is the total ammonia, what is the total water content in this, so that we can find out. Okay, now this 2 point is there, sorry, this 2 point is there, this 2 point is this 2 point is there. Okay, this 2 point, draw a straight line, draw a straight line, horizontal line you can say, intersection of this straight line on this line which is the bubble point line. Bubble point line means किसी भी कंसंट्रेशन पर जब पहला बबल फॉर्म होता है, लोकस ऑफ दैट पॉइंट, locus of that point is your bubble point line. सेम किसी भी कंसंट्रेशन पर, ऑन एनी कंसंट्रेशन, जब सारे का सारा लिक्विड है जो वेपर में कन्वर्ट हो जाता है, दैट लाइन इज द ड्यू पॉइंट लाइन. सो जो 2 पॉइंट हमने सिलेक्ट किया था उसको अगर हम हॉरिजेंटल लाइंस प्लॉट करें, देन इंटरसेक्शन विद द बबल पॉइंट लाइन, intersection with the dew point line will give you the concentration of the liquid, concentration of the vapor. यहाँ पर हमें concentration मिल गई liquid की और vapor की. Now what will be the total mass? Total mass at the 2 point. So total mass at the 2 point will be m total is equals to m2l liquid. 2 point पर liquid कितना था, 2 point पर vapor कितना था. So this is the first part where we can get the total mass. Another thing we can, if we need to know the what is the ammonia, what is the ammonia content at this 2 point, 2 point पर ammonia content कितना है, how we will find out this thing? We know this is the one at the concentration at the 1 point. Can I multiply? We know now, we know that this 2 point, now we know this m total. If I multiply with this concentration at the 1 point into m total, this will give you the amount of ammonia present in the system, which is the ammonia. So again I can this represent this ammonia, because ammonia is present here at this state in a liquid form as well as in vapor form. So that I can convert like concentration at 2 for the liquid, m2l, plus concentration at the 2 point in the form of vapor into m2 vapor. So this is how we can find out the this two relation. So combining these two relation, इन दोनों relation को अगर combine करके I can draw another relation that m2l upon m2v is equals to this concentration of a liquid in the vapor state, concentration at the 1 point upon concentration at the 1 point minus concentration at the of the 2 point liquid state. So this relation I can derive, okay, using these two, 1 and 2. So this is a simple thing by which we can find out the ratio of the liquid and the vapor phase. This is the one thing, okay. And second, this is for the only for one pressure. This is for the one pressure. These two curves here you can see, this curve and this curve, this is representing only one pressure. Same thing can be represented for the another two pressures. So another pressures also, like P2, P1. P2 is higher than the P1. So same for the third pressure also. If I plot like that, this will be represented for the third pressure. Okay, this will be the third pressure. So third pressure, and these 2 points are representing basically, ये दोनों point क्या represent कर रहे हैं? In this is at this point basically this complete water is there. At this point complete ammonia is there. So this was the thing. This is the temperature concentration diagram. Another thing, now we need to find out the enthalpy also. In the previous this figure we can easily get this concentration of the liquid, concentration of the vapors, and total mass of the ammonia, the mass of the water. So these things we can calculate from this figure. Now we need to get the enthalpy. So in order to get the enthalpy, so this is the chart. One thing which we can see this to get the enthalpy, once we know this concentrations, you can use this relation like for फॉर द लिक्विड आई से, अगर लिक्विड के लिए आपको इंथैल्पी HL लिक्विड के लिए इंथैल्पी फाइंड आउट करनी है फ्रॉम द दिस प्रीवियस चार्ट ओनली, wait, from this chart only, if we need to find out the enthalpy for the this liquid point, okay, अगर ये find out करनी है, enthalpy at this of this L basically will be equals to concentration of the liquid into enthalpy at that point of the liquid plus 1 minus concentration of the liquid into enthalpy of the water. This ammonia, basically this is ammonia, this is water, because at this point ammonia is also there, water is there also there. So इस point पर जितनी भी liquid की concentration है उसका कितना quantity अमोनिया के पास है, कितना क्वांटिटी उसका वाटर के पास है, प्लस डेल्टा एच. डेल्टा एच इज वट एवर द हीट एडिशन और रिजेक्शन इज देयर ड्यूरिंग द कॉम्बिनेशन ऑफ दीज टू. जब ये दोनों कंबाइन होंगे तो एक्सोथर्मिक रिएक्शन हो रही है या एंडोथर्मिक रिएक्शन हो रही है बेस्ड अपॉन दैट. सेम फॉर द वेपर्स ऑल्सो. ओके, सो दैट इज द वन थिंग. अनदर थिंग इज दैट दिस डायग्राम इज देयर, enthalpy composition diagram, composition diagram or concentration diagram. You can see ammonia and water is there. In this ammonia and water, this is also at a constant pressure. So is constant pressure पर you can see this line is there. This line is representing again the bubble point line. ये line कौन सी है? जिस point पर पहली बार bubble form होता है as we are providing the heat. So this is the line where the complete water or liquid is converted into the vapors. Okay, so saturated vapor line you can say, saturated liquid line you can say. So this is a subcooled region, this is a mixed region where liquid is also there, vapor is also there. Now you can see this, there is a one additional auxiliary line is there. This is the one additional auxiliary line present here. This is known as the auxiliary line. Okay, so which is used to find out the enthalpy of the mixture. Say we need to find out the enthalpy at this B point. इस point पर enthalpy find out करना है हमने, तो उसका way क्या है? You can take any line, any point basically, any point on this saturated liquid line. Saturated liquid line पर मैंने ये point ले लिया, वहाँ से एक straight line plot की which meets with the auxiliary line. Auxiliary line के meet करने के बाद then draw a horizontal line. Whatever the intersection point is there, draw a line between this point and this point. If this line is passing through this point, then you can get the concentration of this one. That is correct. That is the temperature basically, saturated temperature at this point. Okay, otherwise no. So again you need to check another, take the another point. So ये हमने दूसरा point ले लिया, यहाँ पर line draw की, horizontal line plot, vertical line plot की, then horizontal line plot की, यहाँ पर इन दोनों को point. Again this line is not passing through the B point, तो यहाँ पर एक point लिया. So right now this line is not aware to us. So draw the vertical line, horizontal line, joining these two. If it is passing through the B point, then this is the temperature. This is how you can get the temperature of this B point. Okay, इस B point पर ये temperature होगा, and to get this will be the enthalpy of the B point. Okay, this is how you. But for our this course, for this our course, so this chart is not required actually. So you can use the provide you the data directly, by which you can get all these enthalpy values. Okay, so this is only for the basically knowledge purpose. So this type of chart is there. So previous chart was only for a constant pressure, one single constant pressure. So it can be for different pressures also, as you can see. So in this you can see these lines are for different pressures. Okay, ये सारी different pressure, all these lower lines, जितनी भी ये lower lines are, all these lines are presenting here. Basically ये सारी ये वाली lines है, ये saturated boiling lines है. basically यहाँ पर boil होना शुरू हो जाएगा ये at different pressure. ये सारी की सारी ड्यू पॉइंट लाइंस है, ये सारी की सारी ऑक्सिलरी लाइंस हैं. ओके, दिस इज द एंथैल्पी अमोनिया water mixture. So similar type of graph is there for other combination, अगर ammonia water की जगह पर और combination हम use करें. So this is the final this vapor absorption system for the ammonia water mixture. ये पहले की तरह ही है जैसे हमने पहले किया था. You can see evaporator is there, heat exchanger is there, expansion valve is there, condenser is there. ये तो हमारा वही सिस्टम है वेपर कंप्रेशन सिस्टम की तरह. द ओनली थिंग इज ऑब्जॉर्बर, हीट एक्सचेंजर, जनरेटर एंड दिस रेक्टिफायर इज देयर. रेक्टिफायर इज अगेन आई ऑलरेडी टोल्ड यू टू यूज द टू रिमूव द वाटर, टू protect that water should not go in this here, only ammonia should go this side. So this is the basic cycle. So up to this we discuss about the vapor absorption system. Next we can discuss the one numerical problem on this. This is about the lithium bromide water absorption system. Here you can see generator temperature is given to you 80 degree centigrade, condenser temperature, absorber temperature is given to you which is 30 degree centigrade, evaporator temperature 10 degree is given to you, condenser temperature is given to you 25 degree centigrade. So these temperatures are given to you, and here you can see this steam enters to the generator. So heat कहाँ से आ रही है generator में? That is coming from the steam. So steam से आपके पास heat आ रही है which is coming at 120 degree centigrade, which is dry saturated state steam, and leaves at 100 degree as condensate. Okay, so concentrations are given to you. Here you can see concentration of the liquid लीविंग द जनरेटर. जैसी जनरेटर को लीव कर रहा है वो उसकी कंसंट्रेशन क्या है? 0.65. सो फर्स्टली विल डिस्कस द स्कीमेटिक डायग्राम ऑफ दिस वन. सो हेयर यू कैन सी दिस इज द स्कीमेटिक डायग्राम. I'll pick this up little bit. So this you can see. So here you can see this is the evaporator, this is the evaporator, this is the condenser, this is generator, this is the absorber. So temperatures are given to you. Evaporator temperature is given to you 10 degree centigrade, condenser temperature 30 degree centigrade is given to you, and generator temperature 80 degree centigrade is given to you, and absorber temperature 30 degree is given to you. Anything other is any other thing is given to you, like condensate temperature. Condensate temperature means after condensation what is the temperature? This is the temperature at this point, 2.25 degree centigrade. These temperatures are given to you. So what, anything else? Yes, given data, from the given data you can see this concentrations are given to you. Concentration of the liquid, concentration of the liquid leaving the generator. Generator को जो leave कर रहा है that is 0.65, and its enthalpy is also given to you. जनरेटर को लीव करते हुए दिस इज द पॉइंट, वन पॉइंट इज देयर जहां पर आपको लीविंग द जनरेटर कंसंट्रेशन ऑफ द लिक्विड को लीव करते हुए. सो लिक्विड जो जनरेटर से लिक्विड जा रहा है वो इस पॉइंट पर यहाँ पर जा रहा है. तो यहाँ पर जो कंसंट्रेशन है 0.65 एंड एंथैल्पी इज 75 किलो जूल पर kg is given to you. That is the concentration, enthalpy. The concentration of the liquid leaving the absorber is 0.51, and its entropy is enthalpy is -70. कंसंट्रेशन लीविंग द अब्जॉर्बर को लीव करते हुए कंसंट्रेशन कितनी है इस पॉइंट पर? 0.51 एंड -170 किलो जूल पर kg. So this is the thing given to you. Anything else? This enthalpy of water, enthalpy of vapor leaving the generator. वेपर्स जो लीव कर रहे हैं यहाँ पर जो एंथैल्पी दी हुई है 2620 किलो जूल पर kg. This enthalpy is also given to you. Anything else? This nothing. Yes, flow rate through the evaporator is given to you. Flow rate through the evaporator. This is the evaporator. यहाँ पर जो flow rate है 0.4 kg per second. These things are given to you. Okay. So what is the first question? That pressure in the generator, condenser, evaporator, absorber in mm of mercury. सभी का प्रेशर, सभी का आपको टेम्परेचर दिया हुआ है, प्रेशर नहीं गिवन है. सो व्हाट इज द रेफ्रिजरेंट? व्हाट इज द रेफ्रिजरेंट इन दिस सिस्टम? दैट इज द वाटर. water is acting, or you can say steam, or whatever the state is there. जनरली यहाँ पर जो अगर हम इवेपोरेटर में बात करें, water will be there, water will in a saturated steam state. So at every point, if we'll talk about the water here in the condenser, I'll say the state will be liquid only, saturated liquid. Here state will be saturated steam. So saturation की बात करेंगे हम. So corresponding to that, जनरेटर में जो टेम्परेचर है 80 डिग्री सेंटीग्रेड, वहाँ पर ड्राई सैचुरेटेड स्टीम है. So we'll consider that. So you can refer the steam table and get the pressure corresponding to 80 degree centigrade. Same for the condenser temperature corresponding to minus 30 degree centigrade. What will be the pressure for the saturated pressure basically. Okay. Then for the corresponding to the evaporator temperature के corresponding saturated pressure क्या है, that you can get from the steam table. Same for the absorber temperature 30 degree, you can get the pressure for the absorber also. Okay, so next question was this tonnage. What is the capacity? So in order to find out the capacity, you should be aware about the enthalpy at the 2 point, enthalpy at the 3 point. What will be the enthalpy at the 2 point? So as you are aware, at this 2 point, this after the condensate 25 degree centigrade, that is the temperature given to you. Corresponding to that 25 degree centigrade, what is the enthalpy at the of the H2? Can we find out that enthalpy? H2 corresponding to 25 degree centigrade, which comes out to be 104.75. This is the enthalpy at that point. Okay, then you know the evaporator temperature. Corresponding to that evaporator temperature for the dry and saturated, okay, then you can get the enthalpy at the difference. Mass flow rate, we know the mass flow rate 0.4, which is given in the numerical problem. You can find out the capacity of the evaporator. Okay, the third question query was heat rejection to the condenser and absorber. If you get the enthalpy at every point, entering the condenser, exiting the condenser, you can get the heat rejection, but you need to balance the mass balance and energy balance. So here you can see heat rejected to the condenser is mass flow rate, because in the condenser mass flow rate remains the same. There is no mixing of the with the lithium bromide, only water content is there, so flow rate remains the same. H1 and H2. H1 is, I think, already given to you in the numerical problem. H1 is which is leaving the generator. Okay, this is given to you. H2 you already got it from the steam table, so you can get the this heat rejection in the condenser. In order to find out the heat rejected in the absorber में heat reject find out करने के लिए, so here you can see this is the absorber में M3 mass flow rate यहाँ से आ रहा है, which is 0.1, which is the water only. So यहाँ पर lithium bromide है, here lithium bromide is there. At this point lithium bromide is there, water mixed with the lithium bromide, which becomes the weak solution बनने के बाद वो इधर जाएगा. So यहाँ पर heat gain होगा, यहाँ पर फिर से mass flow rate यहाँ पर आएगा M5, यहाँ पर M4 जा रहा है. So firstly you need to apply the mass balance. So सबसे पहले mass balance लगाने के लिए M3 plus M5 is equals to M4. So यही हमने लगाया, mass को M3 is equals to M3 M4 plus M5 is equals to M3. Oh sorry, M3 M5 equals to M4. Okay, now we can balance the lithium bromide. So here you can see lithium bromide is not going in this direction, lithium bromide is not coming from this direction. Okay, in between this यहाँ पर और यहाँ पर lithium bromide balance होना चाहिए. Okay, उसको balance करने के लिए what we can do, we can set the as per the given concentration x4 x5, mass flow rate at the 4 point into the concentration is equals to mass flow rate at the 5 into the concentration at the 5 point, which should be equal for the mass balance for the lithium bromide. उनको balance कर दिया, this relation we can use, and again from this relation we can put this M4 in this above relation, this one. So here we can get the mass flow rate of the M4 का पता लग गया. Then we can go for the energy balance. Energy balance में here you can see energy balance, M3 H3 is equals to M5 plus into H5 equals to M4 H4 plus QA, which is the QA is what? Energy leaving out, going out to the system, from the system. Okay, इसको balance करेंगे, then you can get this heat, whatever the heat is there. Okay, heat rejected from the absorber. Then in order to find the COP, then generator में हमने energy balance लगा दिया. Generator में energy balance लगाने के बाद you can get the QG निकालने के बाद you can find out the COP of the system. Very easy. So after that you can go for the heat transfer rate in the generator. Q is also given as this. This is how you can calculate the heat generation. Okay. Next one is the relative COP or COP based upon the second law. So this relation you can use. So after using this relation, this will be the COP of the maximum COP, and this is the relative COP of the system. Okay, so these temperatures we already know, and convert those. Earlier this was given in the degree centigrade, convert it into the Kelvin. So because here you can use only in Kelvin. Okay, so this was the numerical problem based upon this water lithium bromide system. Next we'll discuss on the steam jet refrigeration system. So that was the last topic of this absorption system. That is not actually the absorption system, that comes under the category where waste heat is utilized. Okay, so we'll cover the that thing in the next lecture. Okay, thank you so much.